Hi guys and welcome. Today we'll deal with a common question and discussion whether it matters if your tweeter does 25 or 30 kHz or generally just more than 20 kHz of maximum resolution. Oftentimes people blame missing clarity or precision of a speaker on the tweeter being able to only play frequencies up to 20 or 18 kHz, for example. And after some careful thinking and testing of different speakers, you should rather quickly come to the conclusion that the maximum resolution of a tweeter is not a super big factor, especially when it comes to general clarity of a speaker. Reasons for this are that A, the human ear, as most people know, cannot really hear frequencies over 20 kHz, and in the case of most people not even above 16, 17 or 18 kHz. And B, that most of the frequency spectrum of almost any song that is out there does not happen around this area of frequencies. I can't think of a single instrument or commonly used tone in music that reaches 20 kHz or more naturally, and even then you wouldn't be able to hear it. One thing to mention here though is that because music consists of many different frequencies played at the same time, there can be some types of frequency blends or mix, however you want to call them, out of different frequencies overlapping that might reach higher or also lower frequencies than they originally did, which is something that the ear can then technically detect, but today I just want to focus on the more essential and basic part of this discussion. So anyways, these are the reasons why it does not make sense to classify a tweeter's quality and its overall clarity solely based on its maximum frequency range. And like I said before, you just have to listen to prove this. You can have a speaker with a great diamond tweeter that is super expensive and does 50 kHz of maximum resolution, but has a response that rolls off treble at after 8 kHz, and it'll still sound less refined than a normal aluminum dome tweeter that does only 25 kHz and has a rising response after 10 kHz, for example. So it really depends on the tuning and not if your tweeter does 40 instead of 20 kHz or something. But there weirdly still seems to be something about very high resolution tweeters, like mostly AMTs, ribbon tweeters and so on, these types of tweeters that kind of make them special and different sounding from the rest. Ribbons are probably the best example for this because there is just something very refined about all of them compared to many other tweeters, especially dome tweeters. So when it's not the additional frequencies that can be played back that make the sound more refined than other tweeters, what is it then, you might be asking? The reason why the AMTs and ribbon tweeters are able to play back those high frequencies in the first place is because they have a lot less weight to move or because they have stronger magnets than a traditional type of tweeter. So it basically comes down to how fast the moving mass can be accelerated inside of the driver. When you have a car and you want to make it go really fast, you can either remove weight and keep the same horsepower, or you keep the weight and add horsepower. Both things will make the car go faster in a straight line. And now to apply this example on tweeters, a 1-inch tweeter usually is around 0.3 to 0.7 grams depending on its size and material used, while a ribbon tweeter with a similar surface area will be something between 6 and 15 milligrams, which equals 0.006 grams, just to give you an idea of the difference here. And like I said before, if you keep the same horsepower or technically the same strength of the magnet inside of the tweeter, but you remove weight from the moving mass, this will overall result in better acceleration of the driver. With these gains in acceleration of the moving mass, not only comes the advantage of being able to play back those much higher frequencies than a dome tweeter, but also a much faster reaction time of the tweeter. And that's already the point here. Because the reaction time or also the impulse response with these drivers gets so fast because of the increased driver acceleration, they are also able to turn the electrical signal into an actual sound wave that you can hear much quicker than a traditional dome tweeter. And since the range of frequencies that are affected by this is the complete range that is covered by the tweeter, this effect is easily noticeable for your ears. Especially in the presence region where the ear is most sensitive, around 3 to 5 kHz, most tweeters are active already and would hugely benefit from a higher driver acceleration, like in the case of a ribbon tweeter or an AMT tweeter. And especially in these areas, it's important to have a good sound because, like I mentioned before, this is where the ear is most sensitive and this is where most of the music happens and not at something around 40 or 50 kHz. And to prove this, or just to demonstrate it to you so that you can hear it, I'll conduct a little test here using a ribbon tweeter, in fact a very high-end one made by the company RAL. This tweeter will easily do up to 100 kHz and is by many people considered one of the most refined sounding tweeters that is out there. In this experiment I'll just play 3 or 2 different kinds of tracks, and at the first time I'll just play it as always, just normally, and then at the second time I will cut off all high frequencies at around 15 or 15.5 kHz, I'll still see about that, but just around this range I will just cut off all of the high frequencies and only let the lower frequencies below 15 kHz pass through the signal. And then we will hear whether there's a big difference or if there's no difference at all, and this will be the test for today. The reason why I cut it off at 15 kHz already and not at 20 kHz, which is what I originally wanted to prove, is that YouTube itself cuts off all frequencies above 20 kHz anyways, at least as far as I know, so this test would have been useless otherwise. But when I cut it off at 15 kHz, I think YouTube should have no big issue with representing all the important frequencies of this test. But still, please correct me if I'm wrong here. As always, I will be wearing high quality binaural microphones for the most realistic sound impression possible. For these you'll have to wear headphones though, so please make sure to put them up and listen closely.
Thanks to you, I've got a reason to get out of bed, make a move or two. And thanks to you, there's a net below, 'cause otherwise, well, I don't know. And thanks to you. Cannot figure though I've done my level best. I cannot figure though I've done my level best. What kind of cold creature to be living inside your chest? Inside your chest.
A tus brazos otra vez. Llegaré hasta donde estés. Yo sé perder. Quiero volver. Nos dejamos hace tiempo.
As you could clearly hear, the difference in this test was nearly not noticeable at all. In my opinion, the recording without the low-pass filter did still sound slightly better, but this can have a variety of different reasons. When you cut off a speaker, especially when you do it in a rather steep way like I did in this test, phase issues in the upper frequencies can occur, and we also don't know how linear exactly the cutoff is. Some of the differences can also come from the different overlapping frequencies that result in a lower frequency that is then easily detectable for the ear, like I said before already. Apart from that, I think this proves that you shouldn't be too worried about your tweeter doing 23 instead of 30 kHz, because even in this test where the tweeter was already cut off at 15 kHz, the difference was very small to not noticeable. Also keep in mind the tracks I selected are rather suitable for this, so with most modern music the difference will be even smaller, and not all people listen to high resolution recordings and stream in high resolution like I did in this test, so expect the differences to be even smaller in real world scenarios. I really hope that you liked this test and you enjoyed it and could maybe get some new information out of this. Make sure to let me know what your opinion on this topic is, or if I did something wrong that you want to correct, so make sure to leave a comment for this. And if you enjoyed this video, make sure to leave a like as well, or subscribe to the channel to don't miss out on any future uploads. And until then, stay safe, and I'll see you on the next one.